Hey, this is Unit 10, Section 3, Conditional Probability. Alright, so before we do the questions, let's go ahead and get the formula going down here. So for conditional probability, it's a little different than theoretical, different than compound, simple, all that stuff we did before. This is the probability that a second event will occur knowing that a first event has already happened. So the way we would write that is you'd have probability of the second event, B, given the first event, A. Okay, that's not, there we go. So probability of B, that line means given A. So the second one given the first. So what we do there is we're going to have all our outcomes of B out of all the outcomes, or we'll just say all the possible outcomes of A. So in this one, you have to kind of do it backwards. So before we would do the top number over the bottom number, I mean, we're still going to have a top and a bottom for the fraction, but you want to find the bottom number first, and then out of that number, find the top number. So you're kind of working backwards. Okay, so the first one, so we choose a random number between 1 and 20, so kind of like we did before. Find each probability simplified fraction. Okay, that didn't change. So number one, I want the probability of an even number given that it's greater than 5. So first we need to find all the numbers greater than 5 between 1 and 20. Well, greater than 5 would be 6 through 20. That's 15. Okay, so we have 15 numbers. Okay, and these are greater than 5. And you don't have to write this part in parentheses if you don't want to. This just explains where that number came from. So 15 is how many numbers are greater than 5. Now, out of those 15, how many are even? Okay, well, if you want to write them out, you can. So I skip 1 through 5, so I'm going to start at 6. Okay, so I have 6, 8, 10, 12, 14, 16, 18, 20. Wow. Okay, 20. Okay, so because I want to be greater than 5, so I can't do 1 through 4. So out of the 15 that are greater than 5, I have 1, 2, 3, 4, 5, 6, 7, 8. So I have 8, and these are my even numbers. So even greater than 5. So, just like I said, you do the bottom number first, then out of those numbers, you do the top numbers second. Okay, that's why it's the A is second, B is first, because you want to do the A first, the B second. Now, this fraction I cannot reduce, so this would actually be my answer. So the probability of getting an even number given that it's greater than 5 between 1 and 20 is 8 out of 15. Okay, that's number one. I think these probably take a little more practice, but once you get used to it, get the hang of it, it's not so bad. Okay, 2, I want the probability of a number that's less than 15 given that it's prime. Okay, we went over prime numbers, so I want to find the prime numbers first. Okay, if you want to list them all out, we can. Again, 1's not prime, so we'd have 2, 3, 5, 7, 11, 13, 17, 19, right? So I have 1, 2, 3, 4, 5, 6, 7, 8. So I have 8 prime numbers. So those are prime numbers. Now, out of those prime numbers, how many are less than 15? Okay, we have 1, 2, 3, 4, 5, 6. Okay, so I have 6. These are prime less than 15. Okay, so that's where those numbers come from, and I can reduce this fraction, 6 over 8, I can divide by 2 on each, and I would end up getting 3 over 4. And that would be my answer. Okay, so that's how I do conditional probability. It's the probability of one, like a second event, given a first one has already happened. Okay, that's why it's the B given A. So you find A, then out of those find B. So again, your fraction though, your number on the bottom should always be bigger than the top. That should be true because you can't have over 100% probability. That's not possible. So if you have it to where your numbers, like your number on top is ever bigger, you've done something wrong and need to go back and figure out what happened. Okay, so application. So conditional probability with word problems is pretty much what this is. Okay, so I'm going to use the same formula. Okay, so I want a random month is chosen. What is the probability of choosing an even numbered month given it has 3 syllables? Okay, so I want probability of even month given 3 syllables. Okay, so if you want to write that out, you can. So equals. All right, so we got to find the second part first. So 3 syllables. If you go through all of the months, January through December, the number of months that have at least 3 syllables is 6. I know because I went through and counted them. If you don't believe me, you can pause the video and do it yourself. So I have 6 months that have 3 syllables. Now out of those, how many are even numbered? Okay, well, we have, I'm gonna write it down here. So we have January, February, March, April, May, June, July, August, September, October, November, December. Okay, so those are our 6 3-syllable months. Now how many of those are even months? Well, if you know your months, so even numbers, we have February, October, December. That's 3. So out of the months with 3 syllables, there are 3 that are even numbered months. Okay, I can reduce this fraction. This gives me half. And that's my final answer. I mean, hopefully, I know it might seem easy watching me do it and explain it, and it makes sense, but that's why there's homework practice, because you need to be able to do this without me explaining it. So please do the homework, please practice. That's the only way you're going to understand and be able to do this on your own for the quiz and the test. Okay, number 4, a random card is chosen from a standard deck. Okay, we've done these before. Remember, there's 52 cards in a deck, 13 of each suit, 4 suits, 3 face cards, 9 number cards. There's half red, half black, spade, heart, diamond, club. Those are the 4 suits. Anyways, write all that stuff down, or whatever you can, you know about cards if you need to. If you already know, great. Okay, so what is the probability of choosing a face card given it is a red card? Okay, so I'm going to do probability of face card given it's red. Alright, so just like I mentioned earlier, in a standard deck you have spades and clubs that are black, you have hearts and diamonds that are red, so half of the deck is red. So half of 52, because that's how many are in a deck, is 26. So we have 26 red cards. That's the second part. So assuming I already know that it's a red, what's the chance that it's also a face card? Okay, well, how many face cards do we have? We have Jack, Queen, King. So there's 3 cards for each suit, but because there are diamonds and hearts, that's 2 suits. We would have Jack, Queen, King for hearts and Jack, Queen, King for diamonds. So that would be 6 total. 6 face cards that are red. And looking at that fraction, I know I can reduce. I can divide by 2 and you get 3 and 13. And that's it for, I mean, it's the same thing as we just did, except we have word problems. Maybe a little more challenging. Again, though, you have to practice this stuff to get it. Alright, last part, C. Conditional probability and specific probability using tables. Okay, again, I'm finding probability. I'm going to use this table now to help me, and I want a simplified fraction. So not much has changed. Okay, when you have a table like this, first thing that I would do is add, then find the totals. Okay, so I want the total over here for all of these, and I want the total down here for these. Okay, so if I'm going to start just across, so 92 plus 46, you get 138. 81 plus 53, you get 134. Now going down, 92 plus 81, you get 173. 46 and 53, you get 99. And then if I add either across or down, I should get the same number, which I do. I mean, hopefully when you do this on your own, you get the same number. If you don't, I should be able to add the totals on both ends and get the same answer. If you don't, one of your totals is wrong. That would be a good way to check before you do anything else. Because if one of these is wrong, the answer might be way off, and you don't want that. Okay, so I have the table, I have the totals. Now, again, I'm doing conditional probability, so I have condition B given condition A. So I got to find the second part first and then find the first part, like we did before. So A is probability of a student who drives a truck given that it's a girl. Okay, so how many girls or how many females do we have total? That's what we want for that. So this should be the total. So we want total. So okay, so we have a fraction. So our fraction, total number of girls. Well, we look at the female, we added that up, we got 134. Okay. Now, out of that total, out of 134, how many girls, how many females drives a truck? Well, all we do is here, I'll use a highlighter and then get rid of it in a minute. So I only want to look at this row right here, because it tells me on the end, you know, given that it's a girl. So I can only look on the female row. I can't look anywhere else. I don't want to look at males. I don't want to look at anything else. Okay, so in this row, I have my total is 134. That's the total number of girls. Now, out of those, how many drives a truck? That would be, I look at truck right here, that would be this number, so 53. And then you see if you can reduce. I can already tell you that you can't, so this would actually be our final answer. Okay, so hopefully that was not too bad. If you know, maybe the next one will help. Okay, so B is probability that I have a male given they drive a car. Okay, so because drives a car is second, I'm only going to look in this column of car. Okay, again, whatever the second part is, that's your given. Whatever your given is, that's the column or the row that you have to stay in. You can't move outside of that. Okay, so drives a car. So I want the total that drives a car first, because remember, you got to find that number first, then do this the first one second, because it's backwards. So drives a car, I have 173. That's how many I have total that drive a car. Now, in this column that I highlighted, how many are male? Well, we have male here, 92. And then if I could reduce that fraction, you would. In this case, you cannot. So that is my answer. Okay, that's normal conditional probability, because you know you have that vertical line in the middle. That's how you know. But look at the last one, C. It says probability of a male student who drives a truck. That is what we call specific probability. Okay? Specific probability is I have this whole table of data, and I want to know specifically, one subgroup of a subgroup out of the total of everybody. Okay? So if you ever have this, and you'll see this on the homework, it could be on the test. If you do not have the given line, like there's nothing that separates any of that stuff. That means I want specifically that one situation, and since I don't have a given, I don't have the second part, the condition, whatever, that means I'm just taking it out of everybody. So for these, the way I would start is, since I don't have a given, I don't have the second part of my condition, my total is just going to be the total of everyone. So I'm going to have 272. Okay, so specific probability is I want specifically one thing out of everyone included, or all options included, whatever I'm doing. So I have to do the total, which is why we need to add all those up, because we might need it. Okay, so total is 272. And now out of that total, I want a male student who drives a truck. So now you want to find where they intersect for this one. So I want male student who drives a truck. Now if you look where those two intersect, that would be this number right here. That's the number that I want to use. Okay. So I would put 46 on top, because that's male students who drive a truck out of everyone. And now I can reduce, because those are both even. Ooh, so I know I can at least divide by 2. And when I divide by 2, 46 divided by 2, you get 23. 272 divided by 2 is 136. Okay, 23 is prime, so I can't do anything else. So that would be my final answer. So again, when you use a table, you want to do the totals first. You always find the total of the second part, and then out of that row or column, find the first part. And on the last part, the C, if it's specific probability, you do that specific intersection of the row and column out of the total that we found at the very bottom right corner. And that's all you do. And then reduce if you can. If not, leave it alone, and that's it.